Have you ever wondered why glass is transparent? I mean, both glass and this piece of iron are made up of atoms consisting of the same neutrons, protons, and electrons. The neutrons or protons within the glass are no more transparent than those in the piece of iron. Both are the same. So why can you see through glass but not through iron? A foreign content creator showed a graphene material. If you look closely, you'll see a slight black smudge in the middle of a piece of glass. That's graphene, just one carbon atom thick. Maybe it's because there are gaps between the atoms, allowing 97% of light to pass directly through, giving the appearance of transparency. But if there are many layers of atoms, these gaps get filled, and photons can't pass through, making the material opaque like a sheet of graphite. But why is glass transparent regardless of its thickness? The most common explanation online is this: atoms are hollow. If you imagine an atom as a sports stadium, the atomic nucleus would be the size of a pea, and the electrons would be like a few grains of sand in the stands. There's a lot of empty space inside the atom, allowing photons to pass through. So the question changes from why is glass transparent to why aren't most objects transparent? Objects are opaque because the photons of visible light are absorbed by the electrons, which use the photon's energy to jump to higher energy levels. Since the photons are absorbed, the object isn't transparent. However, for materials like glass, the energy of visible light is too low to make the electrons jump. The photons pass straight through the glass, making it transparent. But ultraviolet light photons have enough energy to excite the electrons in the glass, which is why UV light can't pass through glass, meaning glass blocks UV rays. This sounds like a convincing explanation, but there's a problem. If photons aren't absorbed by the electrons, they should pass directly through the atoms without any hindrance. However, light slows down as it passes through glass. If you point a laser at a piece of glass, the light moves at the speed of light in a vacuum until it hits the surface of the glass, where it changes direction and slows down to 2/3 the speed of light. When the light exits the other side of the glass, it resumes its original direction and returns to the speed of light. This experiment has been verified countless times without any controversy. So the question arises, how does light pass through glass and why does it slow down? There are two popular explanations. One is that photons continuously reflect between the atoms as they pass through the glass. Although they still move at the speed of light, the actual path they travel increases, giving the impression that the speed of light decreases. This sounds plausible, but unfortunately it's wrong. Even if photons could reflect within the atoms, the direction and number of reflections would be random. They would scatter within the glass rather than emerging orderly on the other side. The second explanation is that when photons encounter atoms, they are absorbed and then re-emitted. The absorption and re-emission of photons take time, causing the light to slow down in the glass. But the problem is that when an atom absorbs a photon, it doesn't remember which direction the photon came from. The absorption and re-emission process is entirely random. So, the light should scatter uniformly as it passes through the glass, meaning this explanation is also wrong. So how does light actually pass through glass? Actually, all three explanations above are based on the idea that light is a particle. But if you consider light as a wave, it becomes much easier to understand its properties in everyday life. Waves can overlap. If the peaks of two waves in space coincide, they combine to form a new wave with an even higher peak. If the peak of one wave and the trough of another coincide, they cancel each other out. When the shapes and speeds of two waves differ, they also combine to form a new wave. The wavelength, amplitude, and speed of the new wave result from the overlap of the two waves. The atoms in glass are made up of atomic nuclei and negatively charged electrons, and light is an electromagnetic wave. The electrons move in the oscillating electric field of the light, and moving charged particles generate their own oscillating electric field. The combination of the light wave with the wave generated by the electrons results in a new wave that passes through the glass, moving at a slower speed than light in a vacuum. This explains why light slows down as it passes through glass and speeds up again when it exits, without violating the law of conservation of energy. Now someone might ask, if light is a wave, does the mirror reflect the light by somehow bending the wave? Actually, it's not quite like that. The metal surface behind the mirror contains many free electrons. When light hits this material, the electrons oscillate in the electric field, generating secondary waves in all directions. According to the Huygens-Fresnel principle, these waves cancel each other out, except in the opposite direction to the incident light, forming a new wavefront, the reflection in the mirror. This is the basis of technologies like radar. Therefore, the light reflected by the mirror is not the same electromagnetic wave that hit the mirror. It's a new wave generated by the electrons. Some materials also absorb light, like most black objects, which neither transmit nor reflect light. This happens because the electrons on the surface of these materials oscillate in the electric field of the light, causing the atoms to move chaotically, converting the light energy into heat. These materials also emit infrared radiation, and their optical characteristics vary due to the distribution of electrons. If light tries to pass through an object, what do you think will happen? According to the law of conservation of energy, your likes and shares didn't disappear. They were just transferred to me, and I'll take great care of them. Enjoyed the content? Then don't forget to like, subscribe to the channel, and share it with your friends. That way, you'll stay tuned to more amazing curiosities like this. And if you still have any questions, leave them here in the comments.